Hi, and welcome to my course about Graphical User Interface in Python, which is short for GUI. Python offers us a library called Tkinter. In this course, I will teach you how to create and build applications by the widgets offered by this package. I will also thoroughly explain the concept of event-driven programming, how it works, and how it differs from regular coding. Like I have initially stated, GUI stands for Graphical User Interface. GUI is present in every device equipped with a screen that displays a GUI in order to communicate with the user. Apps based on GUI features, often referred to as visual programming. The term based on the fact that the application look is as important as its functionality. GUI applications existence starts first creating a window visible on the screen. Some operating systems offer different visual experience. When the user interacts with the GUI by using mouse clicks or any other gestures, targeting selected GUI elements, the GUI elements which receive such gestures are called controls or widgets. The inspiration behind GUI stems from electrical panels, which contains switches, buttons, etc. In this course, we will not be using regular way of coding in Python, but event-driven programming. Event-driven programming is a code which is constructed to specifically perform a specific task, such as pressing the mouse button, moving the mouse cursor, dragging a selected item under the mouse cursor, pressing and releasing a key, tapping a screen, and monitoring the widget state change, and much more. So this is what event-driven programming offers us. So let's proceed with the practical example and let's create our first application. In this lecture, I will show you how we can create a simple window. The first step is to import Tic-Tac-Toe package. Next, we will access our Tic-Tac-Toe package to retrieve a method called Tic, which offers us a window, and we will assign this line of code to a variable called window. Now, in order for our code to work and function, and for a window to appear on our screen, we have to use a method called mainLoop and apply it to our window. As a result, we should have the following window appear on our screen. So congrats, you have just created your first application. In this lecture, we will change the title of our window, which currently shows TK. We will change it to simple. So the first step is to import our Tic-Tac-Toe package. Next, we'll create an empty window. Next step is to utilize a method called title, which allows us to change our window title. So by placing a string data type of simple as an argument inside our title method parentheses, and by applying it to our window, when we run the following code by again applying the mainLoop method to our window object, we should have a window appear on our screen with the title of simple appearing on our window bar. In this lecture, we will create a button and display it on our window. First, we will import Tic-Tac-Toe package. Next, we'll create a simple window and change the title of our window to simple. which will appear in the bar of our window, of course. Next, we'll create our first button widget by using a class called button. As the first argument, we will place our window object. The second argument is a keyword argument, which allows us to choose a text which will appear on our button widget. Both arguments will be sent to the constructor of our button class. As you can see, it's the button who chooses to appear on our window and not the window. Next, we will use a method called place for the coordinates where the button will appear. Both arguments depict measurements in pixels. Therefore, when we apply the main loop method on our window, a window will appear on our screen with a button in the top left corner with a press title. In this lecture, we will delegate some effects to our button widget when being clicked. So first, Tic-Tac-Toe package will be imported. Next, we'll create a function. This piece of code will be referred to as event handler, as this piece of code will be responsible for responding to a click made on the button. We will use this specific event handler to close the window when we click on our button, which is done with a method called destroy, which contains no parameters and is simply there to terminate the application. So when we proceed on creating a window, changing the title of the window, when it comes to the button widget creation, we have a third parameter called command, to which we will bind our function. Such functions are also referred to as callbacks. Our callback will be invoked when our button is clicked. So when we set our button's measurements by writing the following line of code and apply the main loop method on our window, we will have a window with a button appear on our screen, and when clicked, the window should close. Let's ask the user of our app if they really want to close the window before we do so. Tic-Tac-Toe package contains a module named MessageBox. By using MessageBox Module, we can create a dialog box for the sole purpose to ask questions, display messages, as well as receive user reply. When dialog box is activated, all the widgets become deaf as it grabs the whole of the app focus. After we import Tic-Tac-Toe package, we will import the MessageBox module, which is a part of the Tic-Tac-Toe itself. We'll create a callback, which will be responsible for closing, terminating the window, as well as asking a question before doing so. MessageBox module is equipped with a function called askQuestion, which accepts two arguments. The first one is the title of the dialog box, and the second argument is the question, which will be displayed on the window itself. Both arguments are string data types. When the dialog window appears, it will contain two buttons, yes or no. Whatever our response is, will be assigned to the following variable. So when we set the following condition, if our response is yes, we will terminate our window using the destroy method. So as we create our window, change the title, and when creating a button widget, we will bind our callback to the command parameter. Then we will place our buttons at a specific area of our window with the following line and apply the main loop method on our window object. As a result, a window will appear with a button, and when clicked, a dialog box will appear and will ask us if we really want to close this specific window. And when pressed yes, the window should close. Now I will discuss the place method in more details. The first two arguments are mandatory, while the other two are optional. The X keyword argument describes the position of the button in horizontal position, while the Y argument in vertical. While the width and height arguments are self-explanatory. So when we run the following code, after importing the Tic-Tac-Toe and using the S keyword to give it an alias of TK for short, creating a window as well as creating a button and positioning the button on our window using the place method, after applying the main loop, as a result, a window will appear on our screen and the button widget will be placed at the following area of our window widget. We have another method that is available to us through the Tic-Tac-Toe package called grid. However, unlike the place method, which positions the button based on pixels, the grid method divides the window into columns of equal width and number of rows of equal height. Unlike the place method, when it comes to the grid method, we do not have the full control over the button, but share the responsibility. Therefore, we are not obliged to declare the number of rows and columns in advance. Grid will find the proper number for us. Grid accepts 4 keyword arguments. Row argument represents where the widget will be displayed and occupy the space in terms of row number, while the column in columns, of course. Row span argument will determine the number of neighboring rows the widget, in our case a button, will occupy, while column span represents the same concept, however in terms of columns. So let's proceed with the code. First, we will import the Tic-Tac-Toe package as TK, create a window. Next, we'll create 3 buttons. The first one will be titled on, while the second will be titled button, and the third one we will call it off. We will position the on button at first row and at column 1, while the second button will be positioned at second row as well as the second column, while the off button will appear at the third row at column second, and will expand to other columns with the help of the column span keyword argument. As you remember, when it comes to indexing and positioning of elements, 0, index 0 means 1. As we run the following code, after applying the main loop method to our window, we should have window appear on our screen with the buttons positioned in the following way. Another method to look at when it comes to positioning of button is a method called peg. A peg method with no arguments displays the widgets, in our case the buttons, in one column, one below another. Peg method also possesses 2 parameters, side and fill. For example, when the top parameter, all upper letters, is assigned to side parameter, the widget will be positioned in the top area of the window. When bottom is assigned to the side, which is also in upper letters, the widget will appear at the bottom of our window. And when the right and left parameters are assigned to the side parameter, the widget will appear on the left or on the right position of the window, depends what we choose. When we use the fill parameter, it signifies the expansion of the widget by assigning the uppercase letter of X to the fill parameter. We will expand the widget horizontally. We will expand it vertically if we assign the upper letter y to our fill parameter. If we want to expand our widget in both areas, we can use an uppercase letter of both. So both parameter will be assigned to the fill parameter, and the both parameter or letters will also be in uppercase. So in this practical example, we will use the pack method to position the two buttons which we are about to create so that it occupies the entire window. So we will create the buttons named on and off and use the pack method for coordinates. We will use the side parameter to place the on button at the top and use the fill parameter to expand the widget horizontally. We will do the same with the off button, but position it at the bottom with the help of the side parameter. So as a result, we will have the following window appear on our screen with two buttons. Now we will add colors to our widgets. Button class, specifically its constructor, contains two more keyword arguments called BG and FG. BG stands for background color of the widget, while the FG stands for foreground color, which is the text displayed on the button. So in this practical example, we'll create a window displaying two buttons, on and off, and use the pack method as well to arrange the buttons displayed on the window one beneath another. Both BG and FG arguments accept English language. Therefore, we can assign any color name that comes to our mind. So both our buttons will be of a black color, as we have assigned a color of black to BG argument when creating both buttons. And the text will be in green color, as we have a keyword argument of FG, assignment operator green, when we have created both on and off buttons. So when we run our code, we will have a window with two buttons, on and off, displayed on our screen in a black color and the text displayed in a green color. We can also change the color of the widget when it's being pressed on. We have an argument of active foreground, which replaces the color of the text while we press on the button, and a keyword argument of active background, which allows us to replace the color of the button when we press on it. So in this practical example, we will have the on button replace its color when we press on it, as well as its text. So we will assign a string data type of white to active foreground, and a string data type of green will be assigned to active background. As we run the code, the on button will appear in its original color. However, when we press on it, the color of the button will turn to green, while the color of the text which appears on the button will turn to white color. In this lecture, we will create a label, which is a non-clickable widget, which will appear on our window with the text of label in uppercase letters. First, we will import the Tic-Tac-Toe package as TK, then we'll create our window. Now we'll proceed on to create a label. A label is a class, which is of course a part of our Tic-Tac-Toe package. Its constructor will accept the following arguments. First is the window object, where our label will appear on. The second argument is the text, which our label will display when appearing on our window. We will again use the pack method to place the label on our window. As we run our code, we should have the following window appear on our screen, with the label displaying a text of label in uppercase letters. Next widget I will introduce you to is called frame. Frame is also a non-clickable widget, and it is used to group widgets. I will elaborate more on frame widget when we get to the complex part of our course. For now, we will simply have a rectangle green frame appear on our window. So how can we create a frame? We access the Tic-Tac-Toe package first and retrieve the frame class. The frame class constructor will accept 4 arguments. The first argument is the window object. The second argument is the height of the frame, while the third argument is the width of the frame. And finally, the fourth argument is the color of the frame. We will again use the pack geometry manager, which is of course is a method, which will do the work for us in terms of placing the frame in our window in a proper way. So as we run our code, a window will appear on our screen with a rectangle green frame. In this lecture, I will introduce you to an invisible component called int_var, which doesn't show up on our window, however, is very useful when dealing with a Checkbutton widget. int_var is a class short for integer variable. It is used to store integer values. We cannot simply assign an integer value to an object, which is based on the int_var class, but use a method called set. We will use the int_var to organize an internal communication between different widgets. A regular variable is not effective for such a role. So let's get to the practical example. We will import Tic-Tac-Toe package as tk, create a window, create an object based on int_var class, apply set method to our object, and an integer value of 1 as an argument. Next, we will create a checkbutton. Use the checkbutton class and place 3 arguments. First, the window object. Second argument is the title of our checkbutton, which is handled by the text keyword argument. And the third and final argument is called variable. By assigning the alter object, a bidirectional link between the object and the widget is formed. Checkbutton is a small square box which is usually filled with a tick mark, or it can also be empty, as checkbutton represents 2 state selections. We will next apply the pack method to our checkbutton and run the code by applying the main loop method to our window. As a result, we will have a window with a ticked check button appear on our screen. The reason why it is ticked is because we have placed an integer value of 1 as an argument inside the parentheses of the set method. If we have indicated an integer value of 0, the square box of our check button would have been empty. Now we will discuss the creation of the entry widget and how it works. Entry widget lets the user enter data, whether it's numbers, names, etc. So let's import Tic-Tac-Toe package as tk, create a window, and by writing the following line of code, we'll create the entry widget. Entry widget is also a class, which is a part of the Tic-Tac-Toe package. Its constructor, in our case, will accept 2 arguments. First argument is the window object, where our entry widget will appear on. The second argument is the width of the widget, which not only determines the measurements of the widget, but the number of characters our entry widget will accept. So we will assign integer value of 10. By doing so, the entry widget will accept 10 characters only. We will assign it to a variable, thus creating an object, to which we will assign the pack method. And finally, use the main loop method on our window in order to run the code. As a result, a window will appear on our screen containing the entry widget. In this practical example, you will be introduced to a brand new widget called Radiobutton. And I will also incorporate the Checkbutton widget in order to show how the int_var component works with both widgets. Unlike the Checkbutton, the Radiobutton is a small circle filled with a dot or not. The main difference between the two is Checkbutton works alone, while the radio button works in groups, which means only one of the widgets inside our window can be checked if we choose to click the unchecked widget of the group. The check radio button will change its state. So let's proceed to the practical example. We will import Tic-Tac-Toe as TK and create a window as well. We will then create the int_var component, which will be utilized for check button as well as for two radio buttons. And integer1 will be given to set method as an argument. Next, we will create a check button, which will be titled check, and we will bind the check button using the variable argument to alter object. Now we'll create two radio buttons, which is done using the radio button class. The first two arguments is the window object of where it will appear on, and the text our radio button will display. The variable argument will bind both widgets to the alter object, thus confirming the creation of a group. The value argument distinguishes the radio buttons. Each radio button is obliged to use a different value. Keep that in mind. We will apply the pack method to all three widgets, as well as use the main loop to successfully run the code. As a result, a window will appear on our screen. The check button will be ticked, so will our off radio button, as we have assigned an integer1 to our value argument. As our alter object was initially set to 1, the check button was ticked as well. Every time we press on the radio button, we change the state of the alter object. With the value argument, as the alter object changes its value to one of the possible values specified in here. So this is how the radio button as well as the check button works in connection with the int_var component. Now we will bind our widgets with callbacks in order to have some effects when we engage with the widgets. I will also use a module called MessageBox and use its function called Showinfo, which will have a message appear on our screen in the form of a window when we click on a specific button. Its first argument covers the title of the message box, which accepts a string data type argument, while the second argument will display a message on a window. The second argument, as you can see, is a string data type as well. Let's import Tic-Tac-Toe package as tk, get MessageBox Module from Tic-Tac-Toe package, create a function called effect. Our function will contain a Showinfo, which will show a message box window with a message title and a hello student message. Now we'll create a window as well and two buttons, which will appear on our window. The first button will be titled greeting, to which we will bind our effects function. Using the command argument, we will use the pack method to arrange our widget. The second button will be titled close. We will assign the destroy method to our command argument, which will simply close the entire window when the close button is clicked. We will use the pack method here as well. When we run our code after applying the main loop method to our window, which will have a window containing greeting and close buttons appear on our screen. When greeting button is clicked, which will have another window in the form of a message appear on our screen with hello student message. When we click on the close button, our window will close permanently. Not every widget is equipped with the command property. However, for non-clickable widgets, there's a property which exists called bind. By using the bind method, we are able to bind events to non-clickable widgets. An example of an event is a click made on a mouse or a key pressed on a keyboard. The bind method accepts two arguments. The first argument is the event, which will trigger the callback, and the second argument is the callback itself. The callback, which we will bind to our non-clickable widget, differs from a regular callback, as it contains one parameter. This specific parameter, or you can also call it argument, is here to contain info about the captured event. However, in our practical example, we will just assign non-keyword to it for now, as we will not need any additional information about the widget or about the event itself. So in this practical example, we will use the bind method on our non-clickable frame widget. When creating our frame widget, we will indicate the following arguments in its constructor. First, the window object, where it will appear on, then the height and the width of the frame, and its color as well. Next, we will apply the bind method to our widget. The first argument is the name of the event that will trigger the callback, and the second argument is the callback itself. The following line of code indicates an event of single left click on our mouse, which will launch our callback. So you have just been introduced to the concept of events, and this is one of many you will come across during my course. Next, we will use the pack method for placement and the main loop method to launch our code. As a result, a window with a green colored frame will appear, and when we click on it using our mouse single left click, which is available to us through the MessageBox module, a message window will appear on our screen with a hi message, as we have binded our callback named press, which contained Showinfo Function. Here's the list of events that exist within the Tic-Tac-Toe library. You will encounter some of them throughout this course. So here we have bun-1 event, which is single left click made on our mouse. We have bun-2, which is a single middle click made on our mouse. And finally, bun-3 references to a single right click made on the mouse. Next is bun release-1 event, which is a left mouse bun release. Note, there are also events named bun release-2 as well as bun release-3. Next, we have double bun-1 event, which is a double left click. And we also have double bun-2 as well as double-3 events. And also the bun-1 event is part of the double bun-1 too. If you assign a callback to bun-1, it will be launched as well. Then we have enter event, which is when a mouse cursor appears over a widget. And then we have the leave event, which is when a mouse cursor leaves the widget area. Focus in and focus out events are when the widget gains and loses focus. Return event is when we press on the enter key on the keyboard. And the key event is the user presses any key on the keyboard. X event is self-explanatory, so is space and less events. We have cancel event, which cancels a program. So the tab event is when the user presses the tab key, while the backspace is when the user presses the backspace key on the keyboard. We also have the shift, control, and alt events. For example, the shift is when the user presses one of the shift keys, and control_L is when the user presses one of the control keys, while alt_L references to the user when the user presses one of the alt keys on the keyboard, while the pause and caps lock and escape events are self-explanatory. We have the shift-X, the alt-X, and control-X events. The X key references the key pressed alongside the alt, control, or shift keys. The rest of the events are self-explanatory. Events are actually objects, and the property it possesses contains data about the event itself or about the widget it is currently intertwined with. Here's a list of properties that some of the events are equipped with. We have the widget property, which returns the name of the widget the event is currently binded to, while X and Y describe the mouse cursor's coordinates at the time of the click. The X underscore root and Y underscore root is exactly as the X and Y properties, however, for the screen only. Char property is for only keyboard events. The pressed keys character code will be displayed as a result of utilizing the char property. We also have the type property, which tells us the event type, while num property is for mouse events only, which tells the number of the clicked mouse. The key code property is for keyboard event only and displays the keys numerical code. Now I will put some of the event properties in use to demonstrate how they work. So let's start by importing the Tic-Tac-Toe package as well as the MessageBox module. Create a callback which will serve both label and button widgets. After creating the main window widget, we'll create the label widget and apply the bind method to it to give it a button/one event and a press callback. After the creation of the button widget, we will bind it to the press callback as well, but by using the command property. We will use the geometry pack method on both widgets. Now, before we run the code after applying the main loop method on our window widget, let's dive deep into our press callback. When creating the press callback, we have placed a single parameter, but have assigned a non-keyword to it. Since a button widget is clickable, a parameterless function for a callback is acceptable. Therefore, when the button is clicked, we will reach the if statement as the press callback was invoked with no parameter. We will have the Showinfo function display in the form of a dialog box a message of clickable widget. Now, when it comes to the label widget, as it is a non-clickable, when we click on it, we of course be directed to the press callback. The event parameter will be assigned the button/one event, which is an object of course. As our event parameter no longer equals to none, we will move to the else statement, where we will access the properties of the provided object, specifically the x, y, and num properties, and retrieve its data. So let's finally run the code and press the label widget. As a result, we will have the mouse coordinates displayed as a message, as well as the number of the mouse clicked. While when we click on the button widget, we will have a simple clickable widget message appear as well. Now we will use a method called config, which is short for configuration. By using this method, we are able to alter the functionality of the widget as well as its textual representation after its creation. We will create two buttons which will appear on our window, a switch button and a hello button. We will use the command argument to bind the change callback to the switch button, while the greetings callback to the hello button. Meanwhile, we will also create a regular variable which will contain a boolean of true. Now, as we run our code and the two buttons appear on our window, when we click the switch button, it will take us to the change callback. We will use the global keyword inside our function to effectively change its value. For now, as our data equals to true, we will apply the config method on our hello button by assigning lambda colon none to our command argument, we are able to remove the callback from our hello button. And again, by applying the config method to our hello button and assigning goodbye string data type to a text argument, we are able to change the text of our hello button to goodbye. And if we try to click on this button, nothing will happen as we have removed the callback initially. Before we exit the change function, as you can see, we have assigned a boolean of false to our data variable. So when we click on our switch button again, as data no longer equals to true, it will take us to these lines of codes where by using the config method, where we will change the text of our button to hello again. And we will also bind the greetings callback to our button again. So when we click the hello button, hello student message should appear. In this lecture, we will write a code where we will create a window with two widgets, one clickable one and one non-clickable. We will also incorporate unbind method, which will remove an event from a widget. We'll create two callbacks. We'll create three variables. One will store a boolean of true. One will be a list data type consisting of 4 elements. And one will store an integer value of 0. We'll create a window. We'll create a button of start and stop. We'll create a non-clickable label widget, and by using the bind method, assign the following event. And name callback will be given to it as well. As you can see, we have given a parameterless callback to our button widget, while the callback with the parameter has been binded to our label widget. We don't plan to get any info about our widget, therefore we have placed a parameter of nothing. So as we run our code, a window with two widgets should appear on our screen, a button with a start-stop text and a label with a Tokyo text, as we have assigned index 0 element to our text argument when we have created our label. When we press on the Start Stop button and decide to press on the label, the text will not change. The reason why is because we have attached the switch callback to our button. And as you can see, inside the function, we have placed the if statement. So when we pressed on the button, the data variable equals to true. So we have used unbind method on our label to remove the event from it. And before we leave the function, we have assigned a boolean of false to our data variable. Now when we click on the start button again and click on the label text will keep on changing every time we press on it. The reason why is because when we press on the Start Stop button, we will again access the switch callback. As our data variable does not equal to true, we will bind our label again with the button event and the name's callback. We have placed the global keyword in order to make changes to our variables inside our function. So first, we will increment the number variable by integer of 1 and apply the config method on our widget. And we have assigned the following line of code to our text argument and have incorporated the modulo operator in order for text not to stop operating on our label after every click. We can also use a bind all method on all our widgets, even on clickable ones. But as you can see, we have applied the method on our window, same as bind method. Bind all accepts two arguments, the event and the callback itself. So when we run our code, a window appears with a button, a label, and when we click on each element, a hello message will appear on our screen. If we wish to remove the callbacks from our widgets altogether, we can use the unbind method, which accepts one argument, the event which we have attached to our widgets. In this particular lecture, we will use a dictionary data type approach to access a widget and update its textual representation. A dictionary exists in every widget. So the button which we will create be titled on. We will bind it to the switch event using the command argument. So as we click on our button, we will be directed to our event. Now, as you can see, we placed the global keyword so we can make changes to our button object inside the function. We will access the value of the text property and assign it to our variable. Use the if statement to check if it equals to a string of on, and if it does, we will assign a string of off to our variable. Else, we will assign the off string to our variable. And finally, we will access our property again to update it with a brand new value. So this is how we are able to replace the text of our button to on and off with every click. In this lecture, we will use the cget method to read the values of our properties. And we'll also use the config method to set a new value to the same properties. So we will have almost identical code as our previous lecture. However, I will only replace 2 lines of code. First, I will apply the cget method to our button, place text string as an argument to get the value of our property, and assign it to a value variable. And last, I will apply the config method to our button and place the following line as an argument. Assign the value variable to our property, which we will update the text of our button. So when you run this code, you will get the same result when you click on the button. In this lecture, we will specify the size of our text, which is displayed on our widget, its style, and its name by using a property called font, which is a tuple data type. So let's create 2 widgets, a button and a label. We cannot use the font property on a frame. Please keep that in mind. So as you can see, our buttons constructor contains 3-element tuple. The first element is the font name, second is the font size, and the third element is the font style. All 3 elements have to be a string data type. As for the font style, we can choose a bold style, italic, underline, or overstrike. We will use the grid geometry manager to place our widget in the first row, while our label will be placed in the second row. We will set Arial as font style, size 16, and bold font style for our label widget. As we launch our code, we should have the following window appear on our screen with the following widgets appearing the following way. We have more properties that exist which can help us reconstruct the appearance of our widget button. One of them is Borderwidth, which will make our button appear in a 3D form. Another one is Underline, which highlights the letter we can use to access the specific widget, as this letter is underlined. One more property, which I will use for our third button, is called Wraplength, which places a button in a vertical fashion. So as we run our code, you can see 3 widgets on our window. The first button is in 3 the form. The second button, third letter, is underlined, and the third button is in vertical form. Other properties that can be used along with our button widget are pad X and pad Y, which sets the width and the height of an additional empty space around the widget. And we also have highlight thickness property, which sets the widget of additional frame around our widget when it gains focus. Now we will concentrate on the properties of our widgets, starting with the button widget. So in this lecture, we will use the cget method in order to check the value of our state property, whether it is disabled or not, and the config method to assign a new value to the state property. By using the state property, we are able to enable as well as disable the functionality of a widget. First, the window widget will be created, then the first button, and the first button will be titled On and will be of a green color. I will not use a command property to bind a callback to the button, but the bind method instead. First, the enter event, which is when a mouse hovers over a button, will trigger a callback, and another callback will be triggered when a mouse leaves the button area, which is done with the leave event. Before we proceed with the creation of the second button, we will apply the pack method on our first button. The second button will be titled change, and we will bind the switch callback to it. Take a look at the hover callback. We will write the following line of code, which will allow us to change the color of our own button by accessing the BG property of our button widget and assigning a green color to it. Our out callback will be triggered as our mouse leaves the on button area by again accessing the property, specifically the BG property, and changing the color to red. Now let's take a look at our switch callback, and let me explain its inner workings. By writing the following if statement, we will check the state of our own button if it's disabled or not. We will activate it as well as apply the following text, else if it's enabled, we will disable the widget functionality as well as its text. So let's run our code and see our app in physical form. Let's first hover on our button, and as you can see, it changes its color as we approach it and leave it. Next, when we click on the change button, we should expect the text of our own button to change to off as well as appear unresponsive to our clicks. In this lecture, we will discuss the cursor property. By using this property, we can change the appearance of our mouse cursor when it's pointed at a specific widget. So in our practical example, we will create two widgets, a button widget and a label widget. To the cursor property of our label widget, we will assign a string value of watch, while the string value of mouse will be assigned to the cursor property of our button widget. So after packing both widgets and using the main loop method to run our code, a window equipped with two widgets, a label and a button, will appear on our screen. When a mouse cursor is pointed at our label widget, a watch will appear as a form of a mouse cursor, and when we point at our button widget, a mouse should appear as a form of a mouse cursor. If you'd like to explore more options, you can visit the website indicated below. An important note in regards to the cursor property: the cursor property is available for every widget. In this lecture, I will introduce 3 brand new methods and incorporate them in our code. First method is focusGet, which returns the current focused widget, while focusSet method sets the focus on a widget which this specific method was applied on. The third method is called after, and it accepts 2 arguments. The first argument specifies milliseconds, so integer 1000 specifies 1000 milliseconds, which equals to 1 second, while the second argument is a callback. So how basically the after method works is every second callback will be invoked, the callback which we have specified as the second argument. In this particular instance, we have applied it to our window object as it will contain the widgets which we would like to switch the focus of. So in our practical example, we will first import our Tic-Tac-Toe package as TK, create a callback, then we'll create our window object, then we'll create 2 buttons. First button will be titled on, while the second button will be titled off. We will pack both methods using the pack method, of course, and then we will set the after method on our window object. As the first argument, we will indicate 1000 milliseconds, while the second argument will place our change focus callback. Then we will apply the main loop method on our window object. As we run our code, we should have a window with 2 buttons switching focus each second. As our callback has been constructed the following way. We will first check if the button currently focused is the on button after applying the focusGet method on our window. If it is, by using the focusSet method, we will switch focus to the off button. Else, we will switch the focus to the on button. And we will keep repeating the same process by applying the after method on our window. So our callback keeps on invoking itself. In this lecture, as a result of using the after method on our frame widget, we shall have a window appear on our screen with the frame widget turning back and forth to white and green. So let's proceed to the practical example. First, we will import Tic-Tac-Toe as TK, create a variable which will store a boolean of true, create a window object, and a frame widget of a green color. We have to apply the after method on our widget first before we pack it. If we do otherwise, our event will only work once. As the first argument, we have placed integer 1000 and alter callback as the second argument. We have placed the global keyword next to our variable and used the if statement to ask Python if the variable is true. Then we will use another variable to store a string of white, else we will assign a green string data type to our variable instead. And finally, we will reverse the boolean, use the after method within our function, and apply the config method on our widget to change its color, which is done before the after method. So as a result, we will have a window appear on our screen with a green widget turning back and forth to white and green, which is done with the help of the after method. In this lecture, we will create a simple application containing a button as well as a check button, and each time a button is clicked and a check button is ticked, a message box should pop up confirming the changes indicated in the code. After the window widget, we'll create a variable based on int var class. So we'll create an observable variable based on int var class, which is necessary to interact with the Checkbutton widget. We will then create a simple variable containing an integer value. Our button widget will be titled click, and we will bind it to our message callback. When creating the Checkbutton widget, we will bind it with a callback, which should help us increase the integer value of our variable with each tick. So when we press on the click button, our callback will display the Showinfo message containing the number variable value which we have increased with each click, as well as the current state of our Checkbutton widget, which we are able to get with the help of the get method. So let's run our code to see how our app looks. So when we tick our check button, our message box should appear when we click on the click button. And as you can see, our current sum is 1. So is our state. Now let's uncheck our check button widget and click again on the click button. As you can see, we have again increased our number to 2, while our current state is 0, as our check button has been unticked. In this lecture, I will use the label widget as a display board, which will reflect each click made on a button widget. In order to successfully change the text of our label continuously, I will use a special property called Textvariable, which accepts an observable variable as an argument. So let's get to the practical example, and let me walk you through the code. First, a simple variable will be created, which will store an integer of 0. Next is the window widget. Then I will create a button widget and call it increase, and bind it to a callback, which I will explain shortly. We will then pack the button widget. Then I will create an observable variable, specifically the string var class, and assign it to a text variable. Next in line is the label widget, and as you can see, a Textvariable property will be utilized, which will be assigned a text variable, which of course stores the string var class observable variable. I will set the height of the label widget at 7. What I will do next is use the set method on the observable variable and place a function as an argument, which creates the following string message along with the number argument, which will be transformed into a string data type. And finally, pack the label widget, as well as use the main loop method to run the following code. Now, before I show you the result of our code, let me explain the two functions. We use the global keyword in order to make changes to our integer variable. Next, I will increment the same variable by 1. And finally, apply the set method to our observable variable. And place a function as an argument, of course, with the number variable as a parameter. So when we reach another function through this line of code, which changes the text appearance of our label widget, v parameter will receive the number variable, and the following message will appear on our window, stating how many times we have clicked on our button. So let's run the code. As you can see, a button and a label widget containing a text. When we press on the button, the value should increase each and every time. This lecture, I will discuss the message widget. Similar to the label widget, it will display a text on our window widget. However, what separates it from the label widget is its ability to modify the size of the window automatically after the addition of each text. You will soon see the message widget in action, so let's write the code. After importing the Tic-Tac-Toe package, we will create a callback. Then we will create both window and the button widgets. After packing the button widget, we'll create string var observable variable. When creating the message widget, we will use the Textvariable property and assign to it an observable. Next, we will apply the set method on our observable and place the following string data type as an argument, which will be displayed by our message widget. Next, we will pack the message widget and run the code with the main loop method. So before you see the result of our code, let me explain what will happen. So when our app appears, it will contain a button widget as well as a text will be displayed with the help of the message widget. When we press on the button widget, the size of our window should increase with the accordance of our text. Take a look at our callback, which is binded to our button widget. We modify our observable variable by writing the following line of code. We get the current value and add a new one with each click. So let's run our code and see our message widget in action. It is also possible to use the frame widget as a container, which means when we create a button widget, we will indicate the frame widget as its master widget. So after the window widget, we'll create a frame widget, give it the following width and height, and a green color as well. Now pay attention as we create our button widget. Instead of a window, we will place our frame widget as its master widget, which is perfectly fine. This time we will apply the place method on our button widget and a pack method on our frame widget. Let's run the code. As you can see, we have our button widget with a green background. In this lecture, you will learn how to create a menu, which is a horizontal bar located at the top of the application. The first step is to create a menu object, which is done with the menu class and the window object as its only argument. Next, we will embed it into our window by applying the config method on our window using the menu property and assign to it a menu object. So we have just created a general menu. If we launch our code in current state, we will simply see an empty window. What we need to do is to create a submenu. As you can see, as we have created our submenu, our menu object has been placed as its argument and not a window. In order to place our submenu on the main menu, we have to use the add cascade method, which contains the following arguments. First property is label, which specifies the name of our submenu. And the second argument is the menu property. By assigning our submenu to the menu property, we are able to display the specified submenu on the main menu. When we run our code, a window with the menu containing menu items should appear. Our newly created menu and its items can be accessed only using a mouse cursor. In this lecture, we will add more options to our main menu. After creating the main menu and embedding it within our window, we'll create a submenu. To add a submenu to our main menu, we will use the cascade method. Once again, our submenu item will be labeled more, and when we press on it, it should roll down. Next, I will use a new method called addCommand to extend our menu with a new item and also bind it to a callback. So the following method will be applied on the submenu, as our plan is to add a new item to it. The first argument is the name, and the second argument is the command property, which by now you should be very familiar with. The following callback will be assigned to our menu item. So let's run our code.
When we press on the More submenu item, Close option should roll down and appear, and when we click on it, we should be able to close the entire window, as our callback contains the following code. So we can use two methods to add a submenu item to our main menu. One is add cascade. A submenu item created by this method offers us a selection of items as when clicked or pointed at, pulls down and displays other options. While the add command directly creates a submenu item and places it in a specific area of our main menu. And we can also attach a callback to it. In this lecture, we'll create a cascade which will contain another cascade equipped with multiple submenu buttons. So let's first import Tic-Tac-Toe as TK. Let's also use the MessageBox Module. Create two callbacks. One will serve as a welcome message, while another will close the window. Next, we'll create our window widget. Then we'll create our main menu. For all to work, of course, we have to use the config method and apply it on our window object and place our menu object and assign it to our menu property. Now pay attention to this line of code as we are to create our submenu. We have placed property called tearoff as the second argument. If we incorporate the tearoff property, when creating the submenu and add the add separator method on our submenu, our window should look the following way. No dashes and separator line before the submenu item is rolled. By assigning an integer 0 to the tearoff property, when the menu equipped with the submenu is created and the menu appears on our screen, when we press on a specific item and it rolls down, there won't be any dashes. So this is all thanks to the tearoff property. The add separator just separates the items, the menu items, between one another. So let's proceed with the creation of the submenu and apply the cascade method on our menu object, which will display the submenu on our main menu bar in a cascade form, of course. Then we will use the add command method to add a menu button to our cascade, to which we will bind the following callback. Now we will create another menu item, which will be a cascade and a part of our initial cascade. All is done, of course, with the cascade method. Now we will use a simple for loop, which will help us add multiple menu items with the help of the add command method. So instead of writing 3 separate lines of code, we can simply use the for loop. Next, we will use the add separator method to have a separator line between the new menu items, submenu items. And finally, I will use the command method once again to add a menu item to our cascade, which will simply close the window upon engagement. So when we run our code, the following menu bar should appear containing a cascade within a cascade, and this cascade containing 3 more menu buttons. When we click on the close submenu item, window should close as well. Instead of accessing our menu items using a mouse click, we will bind them to a keyboard key. To complete this task, we will use a property called accelerator, which belongs to the add command method. We will also use the bind all method. This code is almost identical to the previous one. I've only modified our add command method, which was applied on submenu object. And I've added a brand new line of code where bind all method was applied on the window object. Important fact, in regards to the accelerator property, it does not launch callback. it just stores and displays the name of the key on the menu item, which actually triggers the callback. What actually triggers the callback is the bind all method. So when we run our code and a window with a menu appears, and as you can see, it is identical to the previous example, as it contains the same number of cascades and menu items. However, when we press Ctrl W on our keyboard, we should be able to close our application as we have assigned a string of Ctrl W to our accelerator property, which is just a formality, of course, while using the bind all method on our window and placing Ctrl W as the first argument and the above callback as the second argument is what has actually caused the application to close. In order to change the state of a menu item, we cannot use the config method, but a special method called entryconfigure, which accepts two arguments. First argument is an integer index, which points to the menu item, while the second argument allows us to change the state of the menu. So in this practical example, we'll create a menu bar, which will contain a cascade. While this cascade unfolds, it will contain two menu items. When we click on a menu item, we should be able to disable as well as enable another menu item. We will do all this with the help of the entryconfigure method. First, I will import Tic-Tac-Toe as TK, then create a callback. Our callback will contain the following lines of code. We will use the global keyword to effectively make changes to our variable within our function. With if statement, we will check if our variable is disabled. If it is, we will activate it. Else, if it is active, we will disable it, of course. And we will use the configure method to change the state of the menu item. After the creation of the window object in the main menu, we will create a cascade which will store two menu items. One will be titled switch, which will be binded to our callback, and the second menu item will be titled active, which will be disabled initially. When we run our code and press on the open menu bar, we can see our active menu button, menu item, in gray color, as we have set its state to disable initially. However, when we click on the switch menu item, our active menu item button will be activated as our callback was binded to our switch menu item. And we have specified in a configure method index1, which points to the active menu item button. So this is how we can utilize the entry configure method within our menu widget.
Now we will cover the window widget in more details. After creating a list variable, an integer variable, and the window widget, we will use the title method to change the title of our window widget. We will use the bind method, attach a callback to our window, which will be triggered by a single left mouse click. So when we run our code and click on our window, the title of our window should change. As our list data type variable only contains 5 elements, therefore the title of our window will only change 5 times. In this lecture, we will change the size of our window by a simple click with the help of a method called geometry. The method itself accepts one argument and it's a string data type. The left side of the string decorates the width of the window in pixels, while the right side describes the height, and in between, a letter X is placed. So as we import the Tic-Tac-Toe, we will proceed with the callback creation. So we will use the following callback to increase the size of the window if it's less than 500. If it's equal, we will return the window to its original size by updating our window widget's size with the help of the geometry method. So we have two variables, one consisting of an integer value, while another stores an empty string data type. Window will be created, and next, the geometry method will be used to set the size. Next, bind method will be used as our window widget will be binded to our callback. Let's run the code. When the first click is placed on the window, its width and height will be increased by 100 pixels. And when we reach the set limit, which is 500, our window, the size of our window, will return to its original size. We have two methods, minimize and maximize. By using the maximize method, we are able to set the limit to how far we can enlarge our window. So let's proceed with the creation of our window. So after creating our window widget, we will use the maximize method. It accepts two arguments. The second argument is optional, while one is mandatory. The first argument represents the width of the window, which is set at 500, while the second argument is the height of the window, which will be set at 500 as well. Both integer values represent pixels. Next, geometry method is used to set the original measurements of our window, which is set at 200 for both width and height. So let's run the code. When the window appears and we try to use our mouse to drag it in order to increase its size, it gets to the point we can no longer increase the size of our window, which is due to the maximize method. Now we will use the minimize method. Our original size is set with the geometry method, while in our minimize method, we set the limit at 200 for both width and height. So when we launch our code and try to decrease the size of our window, it will stop at 200 pixels, as this is the limit where we have set the width and height of our window. If we wish to cancel the resizing of our window widget, it can be done by using a method called resizable, which accepts two keyword arguments and Boolean values as its value. So when we set both arguments with false Boolean value and run our code, the size of the window should appear as the one we have set using the geometry method. As we try to drag the window widget in order to increase or decrease its size, the result should be unsuccessful. Now we will cover the MessageBox module in depth, as I will use different variety of its functions to help us display different kind of messages on our screen when a specific widget is clicked, which appears on our window widget. The first function that I will use, which is provided by the MessageBox module, is called Ask Yes No. So let's begin by importing the Tkinter package and the MessageBox module. I will create a simple callback where the Ask Yes No function will be utilized, which accepts two arguments. First is the title of the message, the dialog box, while the second argument is the message itself displayed on the dialog box. If you press yes on the widget, a boolean of true will be stored in the variable and displayed in our console. Otherwise, a boolean of false will appear in our console if we press no. So after creating the window and button widgets, we will bind our button widget with the dialog callback with the help of the command property. Then we will launch our code. A window with the ask button should appear, and when we press on it, the dialog box should appear, containing yes, no options. And if we press yes, a boolean of true will appear in our console. Otherwise, if we press no, a boolean of false will appear in our console. Next, I will use the ask cancel function, which displays a message box, OK or cancel buttons. And if we press on the OK button, a boolean of true will appear in our console as a result. If we press cancel, a boolean of false will appear in our console. So after importing Tkinter package as well as the MessageBox module, I will create a callback which will incorporate the ask OK cancel function, which accepts two arguments as well, similar to the ask yes no function. Both are string data types. We will then create a window widget as well as the button widget and launch our code. When a window appears and we press on the click button, we should have an option to press either OK or cancel on our dialog box. And when we choose to press cancel, a boolean of false should appear in our console as a result. Another function, which is a part of the MessageBox module, is called ask retry cancel, which is of course a function. And we can utilize it the following way. So after importing the Tkinter package and the MessageBox module, I will create a callback. Within our callback, I will again incorporate the ask retry cancel function. The function itself accepts two string arguments. The first argument represents the title of the message box, dialog box, while the second argument is the message which will appear on our message box. Unlike the previous functions, the icon displayed is a warning sign instead of a question mark, and the two buttons which will appear are titled retry and cancel. If we press retry, a boolean value of true will be stored in our variable and displayed in our console as a result. Otherwise, if we press cancel, a boolean of false will appear in our console. After window and button widgets, I will pack and run the code with the help of the main loop method, of course. When we run our code, a window widget with click me button should appear, and when clicked, a message box consisting of a retry title, a warning icon, and try cancel buttons. And when we press on the try button, a boolean of true should be stored in specified variable as well as displayed in our console. And if we press cancel, boolean of false should appear in our console. Unlike the previous function, the ask question function displays a question mark icon. And most importantly, when clicked on either yes or no buttons, which will appear on the dialog box, unlike a boolean value, it simply displays yes or no in our console, based of course on our answer. If you press yes, the message of yes will be displayed in our console, and if we press no, a message of no string data type will be displayed in our console. So after going through the regular steps, after importing the required package and module, creating widgets, when we finally run our code, a window should appear with a button, and when clicked, a message dialog box with yes or no buttons should appear, and when we click no, no string data type message should appear in our console as a result. Show warning function is also a part of the MessageBox module, and it accepts two string data type arguments, however, only contains one OK button when displayed. So it's a perfect tool to use when you want to warn the user, and when we press OK, the value is stored in our variable, and as a result of using the print function in our callback, the same message will appear in our console. So let's proceed with a practical example. I will import Tkinter package and the MessageBox module as usual,
create a callback where I will incorporate the show warning function, as well as utilize the print function to display the stored value of our variable in our console. So we will create a window widget as well as the button widget, bind the callback, pack the button widget, and run our code. As a result, a window should appear on our screen with a click button, and when pressed, a dialog box with a warning icon should appear with warning title, single OK button, and be careful, message displayed on the dialog box itself. And when we press OK, OK message, a string data type message will appear in our console. Final function I will talk about that is a part of the MessageBox module is called showError, which can be used to display error information. It displays a red warning icon and single OK button, and same as show warning function returns OK string in every case. So let's follow the code step by step. First, import Tic-Tac-Toe package and the MessageBox module. Create a callback where showError function is incorporated and print the function. And print function will also be placed to display the stored value when callback is triggered. After window and button widget, we will pack the button widget using pack method and run the code. When the window appears and we press on its button, an error message should appear, and when pressed on the OK button, OK string data type message will be displayed in our console. Now we will create a calculator which will perform addition, subtraction, multiplication, as well as division. Let's start with the widgets first, then I will discuss the callbacks. We will utilize the sticky property, which is a part of the grid geometry method. The sticky property will adjust the widget based on its position. We can place the widget based on coordinates. Therefore, we will assign west, east, south, and north to our stick variable, as we will have buttons positioned in every area of our window widget. What will basically happen is if we place a button on the west side of our window widget and there is a gap between the button placed on the east and the west, the sticky property stretches the widget, removes the gap, and structures the button so it doesn't look out of sort. We will create two variables which will store an empty string at the moment. We will then create the main window widget. We will set the size of the window using the geometry method and use the title method to give it a name of calculator. Next is string var observable variable, which will be assigned 0 string data type. As we create an entry widget, we will use the Textvariable property to assign an observable to it. We will use the font property to set the type, size, and style of our font, as well as the justify property to set the entry widget text at the right side, and use the grid method to place the entry widget on our window. Now we will create 6 button widgets. First button will display a plus operator, will be 3D shaped. Button will be of a green color, while its text in white. And its front property will contain the following values. Before we proceed with the second button, we will apply the grid method to place the button at the second row and at column 1. The second button will display a minus operator, will be of a red color, and contain the same properties as the first button, which displays the plus operator. We'll use the grid method to place the button at the second row and at the second column, and again use the sticky property.
Next, we will create the multiplication and division buttons. Both will contain the same properties. The multiplication button will display the multiplication operator, while the division button will display, of course, the division operator. By using the grid method and use the sticky property to properly place the widget on our window, we'll place both buttons at the third row, while the multiplication button will be placed at the first column, while the division button will be placed at the second column. And both buttons will utilize the sticky property, which ensures the widgets are correctly placed at the provided coordinates, regardless of its size. Not to forget, we have used font property to give both buttons the Arial text type, the text size, and the bold style. Next in line is the equal button widget, which will help us calculate the provided numbers. Will contain the same properties as the division button widget. The only difference is the value assigned to the text property will be the equal string operator, and the callback assigned to the command property. With the help of the grid method, we will place the widget at the third row and at the third column. The final widget will help us clear the entry widget screen of numbers when clicked. No surprises with the properties, as it is identical to the previous widget. We'll again use the grid method to place the widget at the second row and third column. Now let's apply the main loop method to check how our calculator looks. Looks nice, don't it? Now let's cover the callbacks. As we want our widgets to be dynamic, let's start with the add widget, and let's visit the addition callback binded to it. We will use the global keyword in order to modify our variables within our function. We will apply the get method on our entry widget to get the current value and store it in the number variable, and assign the plus string sign to our operator variable. Let's visit the subtraction callback associated with the second button. Same concept will be applied here with a global keyword, get method, and before we leave the function, minus string data type operator will be assigned to the operator variable. The next two callbacks associated with the multiplication and division widgets will contain identical code with the exception of assigning the multiplication string operator to the variable, as well as division string data type operator to a variable before leaving the specific function. Now let's check the enumerate callback binded to our equal button widget. We'll use the global keyword in order to check the current values these two variables contain. We will use the if statement to check if the operator variable contains the plus string data type operator, and if it does, we will get the current value of the entry widget, turn it into an integer in order to perform addition, get the current value of the number variable, and turn it into an integer value as well, perform an addition, and store it into the current variable. Next, apply the set method on the observable variable associated with the entry widget and place the current variable as an argument. As a result, the sum of the addition will appear on the entry widget screen. We will do the same concerning the multiplication, subtraction, and division by applying the same line of code. We have one more callback to cover before we launch our code, which is the clear function, which is binded to the clean button widget. We will apply the set method on the observable variable and place 0 string data type as an argument. So when the button is clicked, 0 will appear on the entry widget screen. That's a form of clearing the entry widget screen of numbers. So let's run the code and make sure we can successfully perform addition, subtraction, multiplication, as well as division. In this lecture, we'll create a tic-tac-toe game and play against the computer. In the first part, I will cover the widgets and variables. And in the second part of the lecture, I will discuss the callbacks in depth. So let's start with the window creation, assign the title, and set the size of the window widget. We'll create 9 button widgets, set an empty string data type to the text property for all the buttons. Width property will be set at 4, while the font property for all the button widgets will be set as Arial, size 30, and bold type. Border width will be set at 4. Each button will have different callbacks, of course, while the text color for all the buttons will be set as red. We will use the grid geometry method on all our widgets. The first 3 buttons will be placed at the first row and column 1, 2, and 3. The next 3 buttons will be placed at the second row and at the first, second, and third columns. And the last 3 buttons will appear at the third row and at the column 1, 2, and 3. We'll create a list data type variable and store all the button widgets as elements, and finally apply the main loop method on our window object. First, we will create 9 callbacks dedicated to each button widget, and each callback will contain the same line of code. When we click on a button, we will check the current value of the text property and store the value in the value variable. Next, we will use the if statement to check if the value is an empty string. And if it is, apply the config method on our button widget and assign the string x value to the text property. Else, when we click on the button and it contains either a value of x or o, we will invoke our current callback, the function which we are in, and what will basically will happen is the functionality will be cancelled. Therefore, if we click on the same button again and again, nothing will occur during the program run. Therefore, our opponent, which is the computer, won't make any moves. Therefore, we can press on a new button on our board. Now, within our callback, we will invoke a function called winner, which will be constructed in order to announce the winner and stop the game when the board contains the X mark on the provided locations. So if the button 1, button 2, and button 3 contains X mark, we will announce the winner with the help of the MessageBox module, specifically the Showinfo function, and close the app by applying the destroy method on the main widget. We will apply the same line of code when the X appears on button 1, button 4, and button 7. So we will cover all the angles we have, also the 3, 6, 9, 7, 8, 9, etc. The winner function only covers the user, not the computer part, as we, the user, will be assigned the X mark. Let's return to our button callback. We will apply the after method on our main window widget to launch another function in half a second called computer, which will belong to our opponent, which is the computer. We will use the global keyword to access the bonds variable within our computer function. We will use the randint method to generate random numbers from 0 to 9, which is included, and store it in the num variable. We will access the random generated bonds, hex properties, value, and store it in the new variable. Use the if statement to check if it's empty, and if it is, apply the config method on the randomly generated bond. Assign O mark to the text property and place a color green as the text color. And if it equals to either X or O mark, if the square is occupied, if the bun is occupied, with the help of the after method, we will relaunch the callback in less than a second so it can choose another area of our board. After the computer makes its move, it will access the function hump winner to check if it's won the game or not. By using the if statement, we will check each bun combination to check if it equals to O mark, and if it does, a message will appear notifying us of losing the game against the computer, and shortly after, the app will close by using the destroy method, of course. The lines of code is identical to the winner function, with the exception of checking if each bun equals to O instead of X, which is assigned to us as the users who play against the computer. So let's launch our game and play against the computer.